All right, today we're talking about 2.1, the rectangular coordinate system. This is also a lecture that I went over in pre-calculus the first week, so if you want more of my voice, then you can check out the pre-calculus playlist on the YouTube channel. So, all right, so this reads, excuse me. Throughout chapter 1, we solved several types of equations, including linear equations, quadratic equations, and rational equations. Each equation had something in common. They were all examples of equations in one variable. In this chapter, we study equations involving two variables. To motivate the discussion, consider the two-variable equation, x minus 2y is equal to negative 8. What does it mean for this equation to have a solution? A solution to this equation consists of a pair of numbers that is an x value and a y value for which the equation is true. All right, so we move down here. For example, the pair of numbers x equals 2 and y equals 5 is a solution to this equation because here's our equation, x minus 2y, right? We plug in a 2 for x, we plug in a 5 for y, and we get negative 8 is equal to negative 8, which is indeed a true statement. And x equals negative 2 and y equals 3 is also a solution because if I plug in the negative 2 and I plug in the positive 3, I get negative 8 is equal to negative 8 again, and again we have a solution. Over here, in fact, there are infinitely many pairs of numbers that satisfy this equation. Table 1 illustrates a few solutions to the equation. So there are infinitely many, meaning, well, there are infinitely many solutions, right? These are just 4 of the infinite solutions to the equation x minus 2y is equal to negative 8. Each pair of values is called an ordered pair. So, okay, there it is, okay. So, we're talking about ordered pair, and we use a notation that x, y there, right? You guys have seen that before. So if I were to write this as an ordered pair, I would write negative 2 and 3. The first number is essentially the x, and the second number is the y. And then we plot it on a graph, and we'll get to that here in a moment. Or I'm sorry, on a plane. Notice that the x-coordinate, or the abscissa is first, followed by the y-coordinate or ordinate listed second. Whatever. All right. Let's see. We plot these points on a Cartesian plane or a coordinate plane. Okay. Cartesian plane named after René Descartes, the famous mathematician and philosopher. And this is our coordinate plane. Looks like this. We have the, we're going to make this a little bigger because we're going to have to play with it for a second. Okay, that should be good. Okay, so we have the x-axis here on the horizontal line, the y-axis on the vertical line. Right here we call the origin of the graph, and it has coordinates 0, 0. Okay. And when we talk about quadrants, we start in the upper right, and we rotate counterclockwise. We rotate counterclockwise, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Furthermore, all the points in this quadrant here, and we'll go back to red, all the points in this quadrant, they are both positive. Okay, all the points in the second quadrant, okay, we will be to the left of the y-axis, all right, but we'll still be above the x-axis, so all the points here will be negative, positive. Okay. And that's something I guess I didn't really say, but we'll talk about it real quick. As we move up on the y-axis, we get positive numbers, and as we go down, we run into negative numbers. And as we move to the right, and again, this is in relation to the origin that I spoke about. As I move to the right, I get positive numbers, and as I go to the left, I get to negative numbers. And that's where these signs are coming from when I say the signs of these ordered pairs. So the third quadrant, since we're going left and we're going down, the signs of the points will be both negative. And lastly, since we're going right, it'll be a positive value of x, but then it'll be a negative value of y. That one looks like it's kind of winking at us, doesn't it? Okay. So this example reads, plot the ordered pairs -2, +3, 0, 4, 2, 5, and 4, 6. And state which quadrant or on which axis each ordered pair lies. Okay, so let's start here with -2, +3. So -2, +3, what you do is you start here at the origin, and the -2 means we go left 2 units, and the +3 means we go up 3 units, and we hit this point A. The next point, 0, 4, 0 being the first number tells us that we move 0 units to the left or to the right. Okay, so we just stay here. And then the 4, well, that means we move up 4 units, and as we get to this point. Next up, we have 2, 5. The +2 tells me we go to the right 2 units, and we go up 5 units, and that's this point. And of course, lastly would be 4, 6. We move to the right 4 units, and we move up 6 units. Okay, so A, well, that's in quadrant 2, right? B is on the y-axis, and C and D are in quadrant 1. Now, if we connected these lines, or I'm sorry, we connected the dots, we see that we have a line. Reading here, it reads, the 4 ordered pairs plotted in figure 2 were all solutions to the equation x minus 2y is equal to -8. So this line is of the equation x minus 2y is equal to -8. Every single one of these points that we plotted were solutions to that equation. And let's just snip that and put it on there. Alrighty, example 2. So this reads, not every equation in 2 variables has a graph that is a straight line. One way to sketch the graph of an equation in 2 variables is to find several ordered pairs that satisfy the equation. Plot these ordered pairs and then connect the points with a smooth curve. We choose arbitrary values for one of the coordinates and then solve the equation for the other coordinate. So what does that mean? We'll snip the whole thing here. Okay, so going back to that paragraph I started reading was to find several ordered pairs that satisfy the equation. We need to sketch the graph of an equation to be okay. So we need to plot these ordered pairs and then connect the points with a smooth curve. Okay? So what we're going to do here is we're going to, the last thing was we choose arbitrary values for one of the coordinates. So the arbitrary value here is what we're using. These are the arbitrary values that are corresponding with that particular part of the sentence. And then solve the equation for the other coordinate. And the other coordinate will be these second numbers here. Just try and show the flow of what the paragraph said and what we're doing. So example 2 reads, sketch the graph of y is equal to x squared minus 4x plus 4. Okay, so we choose these arbitrary values of x in this column here. And when we plug in, -1 for x, okay, so we plug in -1 here and -1 there. One second, let me mute this. Okay, so we plug in a -1 for our x values. And when we do that, we get -1 quantity squared is 1, minus 4 times a -1. Well, that turns to a positive 4. So we have a positive 1 plus 4 plus 4. And so we end up with a 9. And so when we plug in a -1 here, we got back a 9. Right? And if we plug in a 0, we plug in 0 everywhere for x, and we get back a 4. And the same can be said for all those arbitrary points that we chose, again, in this column here. All right. Once we just have a bunch of ordered pairs, we can begin to plot those on the coordinate plane. So when we plot, -1, positive 9, let's make this a little bigger. That'll just have to do. Okay. So whenever we plot, -1, positive 9, again, we -1 tells me we go to the left 1 unit, and positive 9 tells me we go up 9 units. And then we plot the point 0, 4, so we don't go anywhere on the x, but we go up 4 units. 1, 1, 2, 0, 3, 1, 4, 4. So all the points are here. And then lastly, on the instructions up here, it says, and then connect the points with a smooth curve. Okay. So what we would do here is once we plotted the points, then we would just connect the dots. And there we go. Okay. Later on in this course, you're going to be able to look at equations like this and tell me exactly where in the world we are, touching that x-axis, where we're touching the y-axis. Then you'll be able to graph it in your head. It'll be a cool little exercise for you by the time you get done with this course. Okay, so example 3. We're going to determine whether the following ordered pairs lie on the graph of the equation x squared plus y squared is equal to 1. Okay, so we'll start off. I'm just going to go ahead and write the equation. Like this. Okay. And then we're going to just fill in the blanks here. Okay, so the first problem here is we plug in 0, -1. Okay, so we plug in 0 for x, we plug it in here, and -1 for y right here. Okay, well, what is 0 squared? Well, 0 squared is 0. Plus, well, what's -1 squared? That's 1. 0 plus 1 is indeed equal to 1. So A works. Okay, let's try B. So B, if I plug in a 1 for x and a 0 for y, well, 1 squared is 1, plus 0 squared, which is 0, and 1 is equal to 1, so B also works. Okay. Next, we're doing 1/3 and 2/3, so we plug in a 1/3 here, okay, and we plug in a 2/3 here. Right. So our math might be a little fuzzy here. So let's actually go ahead and rewrite this instead of just writing over the blue. We'll do 1/3 squared plus 2/3 squared. Okay, so we're going to be using our laws of exponents here. So 1/3 squared, if you recall, what we do is we square the numerator and we also square the denominator. Okay, so this becomes 1/9 plus, and then I square the numerator, which is 4, and I square the denominator, which is 3. I'm sorry, which is 9. So 1/9 plus what? 4/9. Okay, well, 1/9 and 4/9, well, that's 5/9, right? Which is not equal to 1. Okay, so C is not a solution to this equation. And D, well, that just looks ridiculous, right? The negative square root of 2/2 and the square root of 2/2. Okay, so for anybody who is familiar with trigonometry, that might look familiar to you. But let's go ahead and do this. We're going to write this. The x value was the negative square root of 2/2 squared plus the square root of 2/2 squared. Okay, we'll start in here. What is, again, same thing we did in C, we square the numerator and we square the denominator, right? Well, what is the square root of 2 squared? Well, that's just going to be 2. And what's 2 squared down here? Well, 2 squared is 4. Okay, and the negative sign, it is relevant, but obviously if you square anything, it will become a positive number, right? Negative times a negative is positive, and obviously positive times positive is also positive. But anyways, the next one will also be, the square root of 2 squared is 2/4. Well, 2/4 plus 2/4 is indeed equal to 4/4, which is 1. So D is also a solution. Okay. That's how we determine whether a point lies on a graph of an equation. So this reads, in example 2, we plotted several ordered pairs that satisfy the equation y is equal to x squared minus 4x plus 4. The graph of the equation y is equal to x squared minus 4x plus 4 is shown again below in figure 5. So this is what that, go back to our pen. So this is what the graph looks like when we plot it. And again, we have our points that we talked about before, -1, +9, 1, 1, 2, 0. We talked about that before. Notice that the graph in figure 5 touches the x-axis at the point 2, 0 and crosses the y-axis at the point 0, 4. These 2 points are called intercepts. Okay, why are they called intercepts? Well, they're called intercepts because that is where we are intercepting the graph. That is where we cross or touch the axes there. Okay. Definition. So the intercepts of a graph are points where a graph crosses or touches a coordinate axis. And again, the coordinate axis are these, up and the cross that the coordinate plane makes. And you're going to need to memorize these definitions. All right? These are very tough definitions here. A y-intercept is the y-coordinate of a point where the graph touches or crosses the y-axis, right? Y-intercept is where we touch across the y-axis. The x-intercept is where we touch across the x-axis. I was just kidding. Obviously, it's not that hard of a definition to remember. Now this might be a little bit harder, only because it's not intuitive at first. So this reads, the intercepts of the graph in figure 5 are 2, 0, and 0, 4. The x-intercept is 2 and the y-intercept is 4. Okay, an intercept will always have at least one coordinate that is equal to 0. Okay, so notice how it's declared that we have our intercepts at 2, 0, and 0, 4, right? We'll always have at least one coordinate that is equal to 0. Therefore, if we're given an equation in 2 variables, x and y, it may be possible to algebraically determine an x or y-intercept by substituting the value of 0 for the appropriate variable. So let's move this to the side, and let's actually go back and look at that graph, or the equation. What was the equation? x squared minus 4x plus 4. Okay. Let's get us a coordinate plane here. Okay, so before I move on to actually doing some algebra here, let's go ahead and read what this says. Right. So it says algebraically finding x and y intercepts given an equation in two variables. So this is definitely important. This needs to be written down. Finding the x-intercept. So if we want to find the x-intercept, we set all values of the variable y equal to 0. Which, speaking of, probably should have said this is equal to y, right? It's equal to y. Yeah, okay. So if you want to find the x-intercept, you set y equal to 0. And if you want to find the y-intercept, you set x equal to 0. Okay, now again, that might not sound intuitive, right? Because I mean, it would just be a lot more poetic if you said, if I want to find the x-intercept, I set x equal to 0. If I want to find the y-intercept, I set y equal to 0. That's a lot more poetic, a lot more easier to remember, right? But it's the opposite. But here's why. Here's why it doesn't make sense. If I want to find the x-intercept, and again, by the definition of it, the x-intercept is all the values that touch across the x-axis, right? Okay, well right here, my squiggly red line, my squiggly red line there, what is my value of y? Okay, well I'm not going up or down any values in the y-axis. Okay, so that's why we would set y equal to 0 if I wanted to find the x-intercepts. All right, and similarly, here's my squiggles here. If I want to find my y-intercepts, then I would set my x equal to 0 because I'm not moving left or right on my y axis at all. Okay, so that's why it might be kind of counterintuitive there, but it does make sense, and that's why. I was going to, yeah, we'll go into it. Okay, so let's just go ahead and get these numbers, right? It says the intercepts of the graph in figure 5 are 2, 0, and 0, 4. So the x-intercept being 2. So down here, how do we find the x-intercept? Well, we set y equal to 0. And, well, it's not the best example to go for, but let's go ahead and do it. So if we set y equal to 0, right, we would have x squared plus minus 4x plus 4. Well, this equation can be factored into what? X minus 2 quantity squared, right? And then if I solve for x, that takes care of both sides, I would get x is equal to 2, which is indeed what we see here. Okay, and then the next one, the y-intercept, if I want to find the y-intercept, I set x equal to 0. So this would be 0, this would be 0, and my y-intercept is indeed 4, as mentioned here. Okay, so that's that. But we'll get some more examples finding x and y-intercepts right now. Okay, so we'll start with blue. So find the x and y intercepts of the graphs of the given equation. So A. Okay, if I want to find my x-intercept, so we'll start off first with my x-intercept. X-intercept. Then what I need to do is I need to set my y equal to 0. So I'll set my y equal to 0. So we've got 0 is equal to 2x minus 1 over x plus 3. Okay, and I'm just solving for x here. So if I solve for x, excuse me, if I solve for x, I'm going to multiply both sides by x plus 3. Okay, well, multiply both sides by x plus 3. I get the equation 0 is equal to 2x minus 1. And if I solve for x, I get x is equal to 1/2. Okay, so that would be my x-intercept. Let's see, maybe we'll put it down here. X is equal to 1/2. Okay, and if I want to find my y-intercept, I'm going to set x equal to 0, so I've got y is equal to, well, 2 times 0 is just 0, so I've got a negative 1 in my numerator, and then 0 plus 3 was just 3, so my y-intercept is just simply negative 1/3. Okay, so that's it. I found my x, y intercepts by, again, setting the corresponding variable equal to 0. Okay, so now let's move on to B. We've got the square root, so x-intercept, we follow the same way I did A, my x-intercept. I'm going to set my y equal to 0, so I'm going to have the square root of x plus 2, and then plus y, but y would be 0, so plus 0, I can just not even put that there, right? That's equal to 3. If I square both sides, I'm just going to go ahead and do this, we can do this in our head, right? If I square both sides, all right, this is going to turn into a 9, right? And then I'm going to subtract 2. So I'll have x is equal to 7. Okay. Square 9. Yeah. So I'd have x equal to 7, and then my y-intercept. I'm going to replace all my x's with zeros because find y-intercept, I set x equal to 0. So I'm going to have the square root of 2 plus y is equal to 3. And I'm going to subtract the square root of 2 from both sides. So I will have y is equal to 3 minus the square root of 2. Okay. And C, it's done the same way. No, I think, okay, it is done the same way, and I'm actually going to go ahead and do it. So, because I think it's pretty important. So, x minus 1, y minus 3, and 5. X minus 1, y minus 3, 5. Okay. So, if I wanted to find the x-intercept, I'm going to set y equal to 0. So I will have x minus 1 quantity squared plus, and this is just going to be negative 3 quantity squared, right? That's equal to 5. Okay, well, let's do the arithmetic here. So we're going to, let's do this. We're going to square this negative 3, which will be 9, and then it's going to turn into, and now subtract 9 from both sides, we'll have a negative 4 over here, right? So let's go ahead and do that. So we're going to have x minus 1 quantity squared is equal to negative 4, right? And then let's take the square root of both sides. So we're going to have x minus 1 is equal to plus or minus the square root of negative 4. And then, of course, the last thing we're going to do is add 1 to both sides. So we're going to have x is equal to 1 plus or minus the square root of negative 4. So it is a good thing I proceeded with doing C here, because to find the x-intercept, we set y equal to 0, right? We did that, we did the arithmetic here, and then we end up with this x-intercept, right? So at first glance, there's nothing too wrong with it, right? Except for the fact that we've got the square root of a negative 4, right? So how in the world do we plot an x-intercept of the square root of negative 4? Okay, well, it's as easy as you might think. We can't, right? We cannot plot, at least on our Cartesian plane, we cannot plot imaginary numbers. So this means that we do not have an x-intercept for this equation, right? It means we are not actually going to be touching the x-axis anywhere for this equation. So that's what that means. Next up, we've got the y-intercept. So we're going to set x equal to 0. So we're going to have negative 1 quantity squared. We're just going to do that, right? It's going to be 1 plus y minus 3 quantity squared is equal to 5. We're going to subtract 2 from both sides. Not 2, I'm sorry. We're going to subtract 1 from both sides. So we're going to have y minus 3 quantity squared is equal to 4, positive 4, right? We're going to take the square root of both sides. So we're going to have y minus 3 is equal to plus or minus, and then the square root of 4 is 2, right? So we can just go ahead and do that. And then lastly, we'll have y is equal to 3 plus or minus 2. Okay, so this right here, saying y is equal to 3 plus or minus 2, it's saying that we have y is equal to 3 plus 2, which would be 5. 3 plus 2, which would be 5. Okay, it's also saying that we've got 3 minus 2, which would be 1. Okay, so it's just shorthand notation to give us two separate solutions instead of writing them both out. Okay, so again, recap. This tells us that we do not have an x-intercept. This tells us that we do have a y-intercept, and they are located at 5 and 1. Okay, so real quickly, I'm sorry, I've got a frog in my throat. X minus 1 quantity squared plus y minus 3 quantity squared. I'm looking at just the original equation here. All right, this equation is a circle equation, okay, which is why we have two y-intercepts. Right, it's a circle centered at 1, 3 with a radius of 5, and if you were to graph that, you would indeed see that it is a circle that does not cross or touch the x-axis anywhere. But again, we do cross here. Maybe they have a graph of it. Maybe not. That's fine. Okay, so midpoint formula. Excuse me. All right, so suppose we want to find the midpoint, m, we're in big M, okay, xy. I say big M because we know that small m, I don't know if we've gotten to it in this class yet or not, but small m we know is slope, right? So, hang on. So big M, xy. Of the line segment between the points A, so this is going to be point A, so in red. This is going to be point A, this is going to be point B, okay? So notice how this point M is smack dab in the middle of point A and B, okay? That is called the midpoint formula. Right, now this is a formula you need to memorize, but I don't feel like it's abundantly difficult to memorize. If you've got two numbers, okay, for the sake of it, let's just use 10 and 2. But I've got two numbers, 10 and 2, okay, and I want to define the average, right? Well, then I would add them together and then divide by 2, right? So the average of 10 and 2 is 6, right? Well, that's the same thing about the midpoint formula. It's just basically the average, okay? It's the average or the middle, right? And you can also say that, 6 is in the middle of 10 and 2, right? If I go down 4, I get the 6, and if I go up 4 from 2, I get the 6. So 6 is, yes, it's the average, but it's also the midpoint, right? It's also in the middle of it. And that's what the midpoint formula is. It's basically saying what we're going to do is we're going to take my values of x, and so I'd have this x value here and this x value here. I'll add them together, and then I'm going to divide by 2 to get this x value. And the same can be said for y. I'll add my y's together, and then divide by 2 to get that y value. Okay, so the midpoint formula is just here, right? You add your x's together, divide by 2. You add your y's together, and you divide by 2. Right, and that's how you find the midpoint between 2 points. So let's do an example. I'm going to go ahead and snip the picture. I feel like that'll help. Okay, we'll talk about the picture here in a moment. So this problem reads, find the midpoint of the segment whose endpoints are negative 3, 2, and 4, 6, okay? So my midpoint formula, again, was my x's, right, x1 plus x2 divided by 2. I don't like that. Let's try it again. Right? And y1 plus y2 divided by 2. Okay, again, it's just adding my x's and adding my y's. So here we go. It will be negative 3, looking at my x's here, my x values, again, they are the first ones. Okay, negative 3 plus 4 over 2, and 2 plus 6 over 2. All right, well, what is negative 3 over 4? That's 1, so we've got 1/2. 1 divided by 2. 2, it's 2 plus 6, so that's 8. 8 divided by 2 is 4. So my midpoint is 1/2, 4. And that's what we see. Okay, well, let's make it bigger. There we go. Okay, so we see that we do indeed have that point, 1/2, and 4 is the point in between negative 3, 2, and 4, 6. Now, it doesn't matter which point you use first and which one you use second, right? So if we were to say, 4 minus 3, well, that's 1, and then we still get 1/2. And 6 plus 2, well, that's 8, and 8 divided by 2 is 4. So it doesn't matter what you which numbers you put first and which numbers you put second here, okay? You just add the x's and you add the y's, and then divide by 2 for both. Distance formula. Okay. So another formula we have to memorize would be the distance formula. Okay. So recall that the Pythagorean theorem states that the sum of the squares of the two sides of a right triangle, so the sums of the two sides, so this side and this side, the sums of them, meaning that we add them together, in the squares, meaning it becomes a squared plus b squared, right? Two sides of a right triangle is equal to the square of the hypotenuse, or a squared plus b squared is equal to c squared. Okay, this is, we are familiar with the Pythagorean theorem. I think that might just be one of these formulas that you just accidentally cannot forget, right? I mean, I have an uncle who's hasn't been in school or done math or anything, and he still knows the Pythagorean theorem. You just kind of memorize it on accident. Okay. So what this is reading here is it's saying we can use the Pythagorean theorem to find the distance between any 2 points. Okay. So if I wanted to find the distance between 2 points, then I could use the Pythagorean theorem, and this process, I'm pretty sure it spills into probably the next page real quick. Let's see if I can snip it. Did I skip a page? No. Okay, so we'll go and snip the second page as well. So all it's saying is that we can use the Pythagorean theorem. We have our sides, okay? So looking at this line here, if I wanted to find that distance between the 2 points, B and A here, okay, I could use the Pythagorean theorem to figure out that distance, because that hypotenuse would be the distance, right? So what I would do is, as I could denote this side being the difference of the x's, okay, and this side being the difference of the y's, and then I square both sides, or I square them, okay, and then the distance between those 2 points, A and B, I also square that. And if I'm losing you, don't worry, this isn't something that you have to actually memorize. The formula is a lot simpler. This is just showing you, kind of proving to you how we do get this equation. It's not just an equation that pops up out of nowhere. Similar to the quadratic formula that I presented to you a few weeks back. So anyways, you take these, you square them, okay, and maybe it goes on. Yeah, you square them, and all you do is just solve for the distance between A and B, because that would be, again, the distance between those 2 points. If I can, nope, and yeah, here, big finish. So you just do the arithmetic here. You square both sides. We have the square here, so we take the square root of both sides, but we only take the positive value of it, okay? Because the distance between 2 points, right? It's going to be a positive value, right? Again, Kroger is not negative 3 miles from me; it's 3 miles from me. And then once you polish it off, you get this nice, pretty distance formula, which is what we see here. And so if the midpoint would be that I added my x's and my y's together, and then divide them both by 2 to get to my midpoint formula, right? I added my x's, added my y's. The distance formula, okay, is going to be the difference of my x's and the difference of my y's. So I'm just going to subtract, one x from the other, square it. I'm going to subtract one y from the other, square it, and then I'm going to take the square root of that sum, and that would be the distance. Okay. Now, we like examples, don't we, right? Words mean nothing. So let's do an example. So let's go ahead and write my formula down. Okay. So I remember that it was a big old square root in there, right? I also remember I said, okay, so it's going to be the difference of the x's. So we're going to say, x2 minus x1. I said it was the difference of the x's, and we square them. And it's going to be, added with the difference of my y's. And I'm just going to square it. Okay, and that's my distance formula. So what do I need to do here now is denote what's going to be essentially my x2, x1, y2, y1, right? It doesn't matter what you choose, it's just that if you remain consistent. So if I call this point 1 and this point 2, okay, then the corresponding x here would be x sub 1, and the corresponding y here would be y sub 1, right? Because I'm denoting it as point 1. Point 2, then this would be, denoted as, kind of like an x sub 2, and this would be a y sub 2. Okay, so let's go ahead and stop being so confusing and do the arithmetic. Okay, so my difference of my x's. So if I said that this was, 0.2, then I'm going to make that be my x2. So I'm going to say 4, and it's going to be minus, oh good, minus a negative 1. So 4 minus a negative 1, we're going to square that, plus we've got a negative 5 minus 5. So we're going to have negative, that's a horrible negative sign, negative 5 minus 5. Okay, now let's just do the arithmetic again. So we've got the 4 minus negative 1, well that's 5, right? 4 minus negative 1, 5. 5 squared is 25, so we've got 25. Okay, and we've got plus, what is negative 5 minus 5? Well, negative 5 minus 5 is negative 10. Negative 10 squared is 100. So we've got the square root of 125 right? Which we can, this is just not happening, right? Which we can reduce to 5 on the square root of 5. Right? And so that's the distance between these 2 points. So, excuse me, it's not as easy as the midpoint formula, but it's still pretty easy. You just plug things in, and then you just keep rolling. Yeah, 5 on the square root of 5. Okay, well, that concludes our lecture.